Guys, I've been working on this for a minute, so I want you to pause the video, read this, see what you can do, and then unpause it because we're going to talk about it. Truth to be told, this is probably what our notes is going to be like. So let's get to this, and here we go. Pause the video if you haven't already. Alrighty, can I get you back up here in 5, 4, 3, 2, 1. Let's see here. Miss Credence, what would be your first step on numero uno here? So we're going to distribute that 5 into the 10, into the y. That gives me 50 minus 5y plus y equals negative 4y plus 50. Very good. Okay, well done. That's what I would do also. What would you do next here? Vivian, what would be your next step? Sure, like what? Great. That reduces this to 50 minus 4y equals negative 4y plus 50. And again, I like doing it that way as well. That's not the way you have to do it, but I like that because now it looks familiar. It's a two-step equals a two-step, and that feels good to me. How many of you guys, even at this stage, had little alarm bells ringing in your head? Because if you did, that's a good thing. Rex, what would be your next step to try to get this to go? So we're going to add 4y to both sides. And that leaves me with 50 equals 50. Now, the equations we solved or tried to solve on Friday also had this happen where the all the variables were eliminated. But, Crystal, what makes this one different? What makes this different from the ones that we were doing on Friday? Yeah, and last time we got that we didn't get variable equals number either. We get stuff like 8 equals 10 or negative 7 equals 7 and stuff like that. So what makes this different from like 8 equals 10 or negative 7 equals 7, Crystal? What do you think? But this is true, right? That when we asked the universe, when are these the same? And the universe was like, when 8 equals 10. We're like, okay, cool. When does 8 equal 10? Never. But now we asked the universe and it said, when 50 equals 50. When does 50 equal 50? 50 is always equal to 50, which is why we say that this has, got a pencil? Infinitely many solutions. No, because that's a different thing. So this isn't saying that the solution is infinity. That's different. And in fact, the solution to an equation cannot be infinity because infinity is not a number. It is a concept that numbers go on forever. So when your friend says 5 plus infinity, you can be like, error. Not allowed. You can't do 5 plus infinity. That's not allowed. Nope, because that's not. Well, that's like saying what is 5 plus hamburger? Like a hamburger. Yeah, it's a syntax error. It doesn't work. Because infinity is not a number, and I can't add it. Can I get you in 5, 4, 3, 2, 1? Regardless, guys, infinitely many solutions. And here's what that means. Watch this. I'm going to draw a card here. Kenzie, when's your birthday? April 2nd. So I'm going to go negative 42. Why negative 42? Negative, April's 4, 2nd is 2. If I put in negative 42 for y, watch this. Grab my calculator. I said, grab my calculator. There we go. So I'm going to do 5, open parentheses, 10 minus negative 42, close parentheses, plus negative 42, and that gives me 218. On the other side, negative 4y plus 50, negative 4 times negative 42 plus 50, it's also 218. It means you can pick any number for y, and this will always be true. Unlike the other ones, we're saying there is no value for y that will make this true. This is the opposite. Y could be literally anything, and you would get that going. Now, I know what you're thinking. How many of you are deeply concerned that when you type infinitely many solutions into Canvas, you're going to accidentally type in infinitely many solitons? Now, I'm going to tell you guys, when I used to make students type out infinitely many solutions, when people got this wrong, I'm not kidding. The number one mistake that they would make is they would say it had no solution when it had infinitely many solutions. That was the number one mistake. But the number two mistake was that they accidentally typed in infinitely many solitons. And then the number three mistake was a different typo. Like, there were more in infinitely many solitons than any other typo. Like, and I don't know why. Which is why on Canvas, I allow you to write this. On Canvas, you may write IMS. IMS. That stands for infinitely many solutions. Now, guys, doesn't matter. Doesn't matter. If you like, I like all caps because that's just the way that I am. But if you're like, whoa, I'm a rebel, man, and you like do that, like it's going to be fine, okay? It will also accept that. So I want to point out, guys, never, ever, ever do I want to call on you and say, does this have one solution, no solution, or infinitely many solutions? I never want to hear you say IMS out loud. I want you to say infinitely many solutions, because when we just start saying these acronyms, we can forget what they mean, and that can be really bad, right? Like, I remember I saw this news report. This was back when people texting each other was the news. You know what I mean? It's like, wow, this is crazy. But it was this news report about this Australian grandma who, well, let me set the scene. What does LOL stand for? Laugh out loud. This grandma thought it stood for lots of love. So she would send stuff like, happy birthday, LOL, and they'd be like, I guess. Right? Or like, you're graduating, LOL. It's like, all right. But here's where it got really bad. Grandma texts one of her granddaughters. It's like, listen, I heard about you and your boyfriend splitting up. LOL. Right? Yeah, that was no good. I mean, guys, if that means lots of love, is that appropriate? Yes. Oh, it's so appropriate. But guys, if that means laugh out loud, Grandma's a horrible person. So what we're going to say, guys, is even if you write IMS, I'm going to insist that you say what? Everyone, that you say? Infinitely many solutions. Hey, I really appreciate you guys paying attention, doing all the good stuff. You guys are kicking butt today. Thank you. I was on time delay, but very well. Duane had something she needed to say. Let's do it, Duane. Guys, I want to hear Duane. Okay, make it fast. Sure. It's an automated telling machine, which is why when people say it's an ATM machine, it's really funny. Because it's an automated telling machine. It's kind of like the days that students don't have to attend are called SNADs, Student Non-Attendance Day, but all the teachers call them SNAD days. And so it's a Student Non-Attendance Day. Okay, but moving right along, guys, I want to finish this up to give you as much time to work on your self-assessment as possible. Let's see if I can get a little bit of help out there. And this is going to come from Aria. Aria, what would be your first step on number 2? No, thanks. Yeah. And what exactly am I distributing into here? Thank you for saying -4. -4 times 3 is a -12. -4 times a -2 is a +8. T, 5, plus T. And I'm just going to do the same thing over here with your permission. 3 times -9 is -27. Did I make a mistake? Oh, whoops, that's supposed to be a capital. That is indeed a typo. Thank you. That should be a capital. Because if they were a capital and lowercase, those do indeed mean different things. So that would be really bad. No time for that. Let's see here. What's going to be our next step? What would you like to do with this next? And I'd love to get that from Anjana. What would come next? Yeah, so I'm going to do 5 minus 12, which I believe is -7. 8t plus t, which is 9t. And that's -27 plus 9t. That's just fine the way he is. Elin, what's going to come next? What should I do? Yeah, I would subtract 9t from both sides. Gesundheit. And that leaves me with -7 equals -27. Elin, is that true or is that false? It's false. So what does that mean about the second equation? Gesundheit. I'm glad we're talking. So when we asked the universe, Elin, when are these two equal to each other? The universe answered back when -7 equals -27. Elin, when does -7 equal -27? Never. So what do you think we say about how many solutions this has? None. So we're going to say no solution. This equation has no solution. Again, That one, usually I don't get no solitons. There's something about writing infinitely many solutions that turns into infinitely many solitons every time. But still, just to keep typos out, let's make it none. N-O-N-E. That's what happens if there's no solution. I want you to write none. Now that's just on Canvas, okay? In real life, I want you to say there is no solution, or it has no solutions. There is no solution, or it has no solutions. Yes, Jack?
So on number 2, do you have to do like the say it was like 19? Do you have to?
So you're saying when you get here, can you just say no solution?
No.
Because
Can we just say? Can we do the like plus 27 instead of doing the 90?
oh, sure, you could. And that would give us 20 plus 9t equals 9t. I'm not sure that that's more helpful.
All right.
I mean, it's a legal move to add 27 to both sides, but it's also a legal move to divide both sides by 12. You know what I mean? And there's just not necessarily the most useful way to do it. Again, you can do it however you want to. I recommend moving the variables. My recommended steps are turn it into a two-step on each side, move your variables over, try to solve it. And that's all there is to it. Let's look at number 3 here. Now, number 3, I'm going to tell you right now, is the most frequently missed question from this unit. Not necessarily this particular one, but things that do this freak students out. So let's see what happens here. Juliet, what's step 1?
I just dropped down the 6p and then I distributed the -7.
And what did that turn into?
-14 plus cos 7p.
Mm-hmm. And then over here?
And then I just dropped down the 10p minus 14.
Love to see it. Okay. What would you like to do next, Alex? Okay. Again, that's not what I would do, but it is a legal move and totally allowed. So now it says 6p plus 7p equals 10p. What would you do next, or what would you have done previous if you did it a little bit more like I did? Garrett, what would your next step be?
I did it the same way Alex did.
Cool. What was your next step then?
You just add the 7p and 16 together.
So 13p equals 10p. Okay. Now, how many people here by raise a hand stopped there and said no solution? I regret to inform you that is incorrect. Remember, guys, I'm telling you right now, that order I gave that to you in, right? Simplify the expressions till it looks like a two-step equals a two-step. Move your variables over and attempt to solve the equation. Again, that is a suggestion that I have for you, and it's not just like, oh well, every way is just as valid, and it's true that every way is just as valid, but I suggest that particular way to keep you out of this particular trap, because I don't like that there's variables on both sides right now, and I would like to change that. There are variables on both sides, and I don't care for that. So how can I change this so that there are not variables on both sides? Duane, go ahead. Or yeah, I could take away 10p from both sides if I so desire, and I do. That means the left side turns into 3p, but what's 10p minus 10p? 0. 3p equals 0. Now, that freaks people out, but guys, that's just an equation. I can still divide both sides by 3, and that means that, what is 0 divided by 3? 0 is 3 times what? Everyone, 0 is 3 times? P is equal to 0. Oh, if you do 3 divided by 0, you better believe that's an error, but that's not what I'm doing. I'm doing 0 divided by 3. That's okay. That's why I did it, right? I did this specifically to cause this to happen. So it turns out that this has one solution, and that solution is 0. That's different than no solution. Here's your 3 outcomes. Well, let's just do it. Let's see here. It is the 31st day of school. Did you guys know that only 2 numbers have a sum of divisors of 31? One of them 16. Here's what I mean by that. Give me a list of all the numbers that go into 16. Go. 8, 4, 2, 1, 16. If you add them all up, 8 plus 4 is 12, plus 2 plus 17. That's 19 plus 12. That's 31. There's only other one number that does that. Does anyone know what that is?
23.
It is not 23, because if you do 23, the only numbers that go into 23 are 1 and 23, and then it becomes 24. 31 is definitely not it, because that 31 goes into 31, and that's already 31, and you have to add the 1. Hey, you guys can work on figuring that out later. It's National Attend Your Grandchild's Birthday Day. This holiday confuses me. Can someone tell me why this holiday is very confusing to think about? Why is this holiday confusing to think about, Mo? Yeah, what if you're not Melissa and your birthday is not today? Right? What if you're not Melissa and your birthday is not today? Now, how are your grandparents are supposed to, like, for example, Mo, when's your birthday? How are your grandparents supposed to attend your birthday on September 29th if your birthday is in June? So, alrighty, let's see here, guys. What is our first essential question? And I would love to get that from Bennett. Let's write that down. How can I tell if an equation has one solution, one solution, no solution, or infinitely many solutions, not infinitely many solitons? While you guys are writing that down, our Jeopardy band members countdown. Despite the number in its name, this band has 6 members who made it big with songs like This Love, Sugar, and Moves Like Jagger. That's right. There are 6 dudes in Maroon 5, and I find that very confusing. Also, the countdown idea is this. Tomorrow's band is going to have how many members? 5. How many is going to be on Wednesday? And then on Friday, I'm going to find a 2-piece band. And then, I don't know, we'll see. And then board games, Candyland. Candyland's what I'm looking for. Huzzah. Okay. Now, guys, here's the deal. I don't have a whole lot of notes for you today past our warm-up, but let's have a quick discussion. See if we can keep that under like 5 minutes so we can get you working on your self-assessments. Got a pencil? How many solutions practice? To tell how many solutions an equation has, your step 1 is to, go ahead and stop spinning that for me. Your step 1 is just to attempt to solve it. And there's 3 possible things that can happen. One of them leads to one solution. One of them leads to infinitely many. And one of them leads to none. One solutions, those act the way we expect them to. Like x equals negative 10. That's one solution. 14 equals b. Z equals 1.34 repeating. T equals 0. Those are all one solutions, right? It's a variable and a number. That sort of acts normally. It comes up with one solution. If you get one of those on Canvas, just give me the solution. Infinitely many solutions when you get something that is true, like 8 equals 8. Negative 13 equals negative 13. X equals X. That's not what I wrote. X equals X. 0 equals 0. Those all mean infinitely many solutions when you get something that is true. No solutions when you get something that's false, like 8 equals negative 8. 2 equals 7. 0 equals negative 9. 13,348 equals 6. These are all no solutions. So if you try to solve an equation and one of these happens, if it acts normally, great. It's got one solution. Tell me what it is. If it comes up with something that is true, then we go ahead and do that, and then we say there's infinitely many solutions. If it comes up with something that is false, then we come up with those. There's one last thing I wanted to say, but I didn't want you to write it down. Go ahead and put your pencils down. There was one year I had a student do this. And the year I had a student do this was on the first problem here, we got to the part where it said, oh, no, it was on the third one. Yeah, we got to the part where it said 10p equals 13p, right? You remember that?
Yeah.
And they said, Mr. Petersen, why doesn't that have no solution? If I divide both sides by p, the p's divide out, and now it says 10 equals 13. Doesn't that mean no solution?
Oh, yeah.
That's a great question. But I can tell you that you've actually broken a mathematical law just now. You just broke a mathematical law. Does anybody think they see what it is? What do you think it is, Jack?
You can't divide numbers you don't know.
Well, I'm going to say you have to be careful when you divide numbers that you don't know, because there is a specific number that we can't divide by. Credence?
Maybe if you do the same thing with both sides, it will always be the same. It will always be equal.
Not quite, because that's how we came up with this weird stuff, right? We did the same thing to both sides, and we were coming up with stuff that wasn't equal, right? Samuel? P is equal to 0. And when you divided both sides by 0, you divided the zeros out. And 0 divided by 0 isn't 1, and neither is it 0. When you divide by P, and if that number is 0, you can break math. So if you don't know what it is, you have to be careful. What you could do is you could say, if I do that, then P doesn't equal 0. So what I would say is P is nothing except maybe 0. And then you have to check if 0 works, and it does, and then you're good. Okay? Well, will you guys open up your planners to page 42, please? Open up your planners to page 42. So we're going to turn to page 42 in our planners. That's going to be Monday the 29th. Page 42. 42. 42. Okay, 42. Okay. Now, guys, on page 42, you're going to write down today's self-assessment is 4.2. How many solutions? Okay. Page 42 is how many solutions? And then if you guys will actually write in on Wednesday the 1st, Wednesday, October 1st, that's your how many solutions skill check. On Wednesday, how many solutions skill check? Okay. So once you get those written, guys, when I say teach, you can open up your Chromebook and go ahead and start working on 4.2, how many solitons? Give that a try, and here we go. In time, Finley, many solitons. Teach! All right, good luck, everybody. Those of you at home, we'll see you